Hey there guys, it's been a little while since I made a video, but this one's going to be kind of fun. Should be fairly basic, but I'm going to demonstrate single wire earth return is the concept that we're going to talk about right now. And I've got a bunch of scrap wire here that I'm going to piece together. I'm going to use a single conductor to turn on a light bulb about, I don't know, 100-ish feet away. I need to step it off to see. But we should be able to get a light bulb to turn on with nothing more than a single wire, and that's it. So think about that for a minute while we get this set up. What a beautiful night. I should have just used a new roll of wire probably, but part of being a Solstrom means that by nature you use it up, wear it out, make it do or do without. Scare you, Freya? We're getting closer, but this is only 6 feet at a time. I should have probably abandoned this scrap wire. Let's see if this reaches here this last little bit. I literally have one wire nut left in my pocket, so I'm hoping this is going to reach. Oh yeah, we are good to go. With single wire earth return, just like the name implies, you use the earth, the physical dirt and the minerals and everything that connects the earth together is the return path back to the source. Now in this case, the source that we're working with is a transformer located right over here in my yard. Single wire earth return. So let's go get this hooked up over on this side over here. Now I tried to go as far away as I could in order to make sure that you guys can see that this is legit and I'm not pulling any pranks or anything. I actually don't even know if this is going to work yet or not, so you're going to learn along with me. I'm pretty sure it will, but we'll find out. I'll be embarrassed, I guess. I don't know. You probably wouldn't be seeing this video if it didn't work, right? This video is for educational purposes only, as always, and anything that is done in this video is not necessarily meant to be copied or repeated. A very important thing to note in here is that we're going to have to use a standard breaker, not a ground fault breaker. This one right here is a dual function. If we were to use that, it would sense that there's not an equal amount of current leaving the breaker and coming back to the breaker on the hot and the neutral. A standard breaker won't know the difference. It's just measuring how much power is going through the wire and it's protecting the wire, but not necessarily for a ground fault. Because by definition, we're going to be creating a ground fault with a single wire earth return setup. For those of you that are wondering, those clamps right there are measuring how much power my property is using. We are using 2,555 watts total on the premises. And that all goes down through this little box right here. It's called the Sense Energy Monitor. If you guys are interested in adding one of these to your property, you can do so by clicking the link in the description and using the discount code Benjamin at checkout for, I believe it's $25 off your order. So if you're interested, check it out. Now we're going to leave this off for the moment until we are ready to actually come back and turn it on. I really should have started on all this a little bit earlier. Hopefully we can get all this done before we run out of daylight. But the good news is once we get it all set up, in theory, we should then have light, right? We'll find out. Check out that sunset though. All right, here's what we got going on. You guys gotta see this on this side, otherwise you might not believe me. So over here on this fence post, this is the earth return that we're working on. I've cleaned a spot of paint off of this right here, and all we're gonna do is take our vice grip and clamp this into place. And this is gonna be our return back to the source. So we've got a wire now, so we can easily connect this onto something. And that something is gonna just be a regular receptacle. I'd be really interested to know if you guys have done anything with single wire earth return systems before. This is something that's actually used in certain parts of the world, surprisingly, or in certain situations where they're trying to get power to an extremely remote area. Because obviously a single conductor or a single wire going out to a location is going to be way cheaper than having to run multiple conductors. So it's got definite downsides, and you would never really see this used in the situation that we're using it today. This is just for demonstration purposes, but it's always going to be in a more intermediate voltage like 7200 or 10,000 volts, where you would actually be using that for a single wire earth return. I'll make sure I put some links in the description if you guys want to read more about it. So we'll start by hooking the return path, which is white, which is what it's supposed to be. This is our neutral, going back to the center tap of our transformer. I made a quick sketch here so that we can kind of visualize what's going on a little bit better. We've got a transformer here, 7200 volts coming in, 240 volts coming out. The way we get our 120 volts is there's a center tap on that transformer, and if you measure between either side, you get that 120 volts. Now, the neutral is also called the grounded conductor because if you follow it, it actually leads to where it is tied to earth with a grounding electrode. And that actually goes back on the utility as well, and the utility neutral is also referenced to earth over and over again with ground rods on many of the power poles. So we have this grounded conductor, which is what allows us to use the earth as a return path. So if we follow the electricity, you can see we go out here, we go up to the light bulb on the top of our fence post, and then it comes back down the fence post, on the fence post itself, since it's a metal post, and then the base of that is in the earth or the dirt, and that is what's going to allow us to make that final connection and return to the source through the dirt itself, back onto one of the grounding electrodes, back onto the neutral, and ultimately back to the source, which is our 240 volt single phase transformer. So that kind of visualizes what we are trying to accomplish, and hopefully gives you a better understanding of what we are working with. Alright, our neutral is now connected, so you can see we've got our half of our outlet ready to go. Now we're going to take our power coming from our breaker over there, and this is still off. There's no power on it at the moment. So I'm going to strip this back a little bit more here, and we'll hook it to the hot side of this receptacle. All right, we are ready to go now. All right, everything is rigged up here. So what I think I'm gonna do is I'm gonna turn the switch on. Now we're gonna use this little bulb adapter, handy dandy thing here, and we're gonna just plug this in. This is just a standard LED bulb. It probably takes less than 10 watts. That's gonna be the most important thing that we keep in mind, is how much load can we actually put on this, because what we're relying on is a connection between this fence post right here and the dirt. Now I've purposely connected it to this fence post to illustrate in the strongest possible way that this concept is very simple. It doesn't require really specialized ground rods or anything like that. So let me just pan down here so that you can see this just goes down into the dirt right down here at the base. Oh no, this is a solar light. I don't want you guys to think I'm cheating. All right, so right down here, nothing happening. Down at the base of this post has been here for a pretty long time. And then we've got our blue wire, which is our hot wire, going down. I just kind of wrapped it around the fence post for stability. And then that feeds all the way across, laying on the ground, back over to where our circuit breaker is located. Now, personally, I think we're going to have enough power to turn this on, but there's a chance that it might act kind of weird if this is too much load for our return path, which is going to have a really high resistance. Let's check it out. I'm gonna put the pets away though first, so. Come on, Freya. Come on, Henry. Come on, guys. Now the distance that we traveled with our wire shouldn't have too much to do with anything, but let me just step it off here just for fun. 10, 20, 30, 40, 50, so a little over 50 steps. So we're at least 150 feet away, and we're using some 12 gauge scrap wire, and the only return path back to the transformer is the dirt. The earth that I am standing on right now is transmitting that return power, and it's working absolutely perfectly with this LED bulb. So what I'm curious about is what kind of voltage are we working with right here? Are we getting a full 120 volts to this light, or are we working with less than that? So we'll go ahead and take our electrical tester and get it rigged up here. Volts, alternating current. Now I'm going to be mindful of not touching the post, because right now it is the return path for the electricity going back to the source. But let's just go ahead and see what kind of power we're getting out of this receptacle right here. So I'll go ahead and stick my probes in here. Alright, we are at 115, 116 volts. I'm just going to turn the power off here on the switch. So what I'll do now, I'm going to stick my probes in here so that they're just kind of stuck in place so we can get continuous voltage readings. And I'm going to unscrew the bulb a little bit so that it doesn't come on. So now we have the bulb unscrewed. I'm going to turn the power back on. I believe it should read about 125 volts now, which means it's drawing down that voltage to by about 10 volts, which is more than 3%. So we know that our return path isn't super efficient, but at 115 volts, it's still plenty of voltage to where we're not going to damage this bulb. Let's go ahead and check that theory out and see if I'm correct. All right, I'll go ahead and turn on the switch. And we're at 123.8 volts. Now I'll go ahead and screw the bulb in. Wait, can you guys see that? You can't even see that, can you? So right there with the bulb disconnected, we're at 123.8 volts, so pretty close to 125 like I was expecting. But we don't have any load on the system at the moment. So I'm going to go ahead and screw this bulb in now, and it should draw that down probably. And there we have that 116 volts. So it's drawing down our power, and that's based on how much is available. See you later! So pretty interesting. So right now we have about 125 volts, and then when we thread this in, our voltage is now at 116 volts. Now, what I want to see is what is the voltage gradient down on the ground, because that's the most dangerous thing about single wire earth return, is that around your grounding electrode, where you're basically making your connection to the earth, you're going to have a voltage gradient. Now, if we were to make this be a dead short to the post, what that will cause is a significant voltage gradient from 120 volts down to 0 volts over just a few feet. Right now though, it should be only a few volts difference between the base of the post and the dirt a couple feet away. Let's take a quick look. So what I'm going to do now is I'm just going to test the difference between the ground a few feet behind me here. Let's see if I can kind of stretch these out and see how far we can make it. It's probably only going to be about 3 feet or so. So we've got one probe in the dirt right there. My expectations for what that voltage difference is going to be that 125 or 124 volts down to 116. So like 8 or 10 volts would be my guess. Let's see if we can pick up what's going on here. .5 volts. Right there, 8.6 volts. So this shouldn't really be a super dangerous amount of electricity. Because we're putting such a small load on it, it isn't creating a huge voltage gradient. Now let's just check in the dirt. Between these 2 points right here, we have 1 volt difference. Now if we move this a little bit closer, now we're at 2.6 volts. Move it a little bit closer yet, kind of right down like an inch away, 3.6, and if we go right next to it, then we're at that 8.8 or 9 volts. Right now we're putting a load of about 10 watts onto our single wire earth return system. Let's try increasing that with this 15,000 lumen 120 watt bulb, which I'm pretty sure is going to exceed what this is capable of, because the bottom of that post isn't very big. All right, let's see what happens here. Real quick, I'm just going to take an amp reading and see how much power we're drawing. 0.1 amps, so 1/10 of an amp, which is about 10 watts-ish. 10 or what would it be, 11.6 watts or something like that. All right, let's go ahead and switch it to the bigger bulb. What's your prediction? Do you think it's going to turn this thing on, or is it going to flicker or cause some kind of malfunction? Hopefully I don't burn this thing up, because it is kind of a nice bulb. It's also going to definitely blind me. if it does come on. Whoa! Oh my! Yes, it came on. Surprisingly. Let's see if we can hang this thing on here somehow. Wow! That's crazy! Oh my word! Alright, how much is this drawing then? That's insane! That's absolutely crazy! I did not expect it to work on this bigger bulb. We'll go ahead and see how many amps we're drawing. We're drawing 0.64 amps. My guess is that the voltage is significantly reduced. So let's go ahead and probe that here really quick. 77 volts. So somehow this bulb is still working even on a reduced voltage. So that means that our voltage gradient down on the ground would be much greater. The difference of basically 80 to 125. So that's what, 44 volts or something like that, 45 volts. So there's a definitely more danger involved when we put a more significant load. Plus, if we were to let that thing keep running, I'm not sure how long the bulb would actually continue to function. But either way, the single wire earth return system is working absolutely flawlessly. You just might die if you accidentally touch the wrong thing. So that's the major downside. Slight downside anyway. But wow, that is really cool. All right. If we wanted more power available with a single wire earth return system like this, all we would really need to do is increase the surface area of our grounding electrode, which is allowing us to basically connect to the earth. Because the earth itself is a very good conductor, but sticking a little piece of metal into the dirt, that's where our problems come from, with that connection being not significant enough to really get a good connection. So if you have something like a large piece of metal that is encased in concrete, like a UFER, something like that is going to allow you to have a much better return path for something like this. Now, as far as I understand, with the single wire earth return systems, in some instances, they'll actually bury or put a significant amount of metal into like a body of water, like at the bottom of a lake, and use that as the connection point back to the grid. But you can see that with this setup right here that we've got going on, we could actually use this functionally to get some power way down my driveway, like to the end of the driveway, to have like a security camera plugged in over there. We could probably make it work, and we could probably make it be relatively safe even if we were to bury a single wire a couple feet deep all the way down to the mailbox. And then when that comes out of the ground over there, we could actually install a GFCI receptacle and make it work on a single wire earth return setup, which would be super interesting. Maybe we'll experiment with that later. But the biggest thing that's kind of a bummer is that this technically is not acceptable for code compliance. This is not something that the National Electrical Code would allow you to do or wants you to do, but it has a lot of safety downsides, like voltage gradients near the electrodes, as well as there is no way to protect the entire circuit with a ground fault circuit interrupter. You can only do that once you have basically come out of the ground with that wire. You could theoretically make it work there, but the entire wire from the mailbox, if we keep using that as the example, back to here, back to the transformer, would not be GFCI protected, and if you were to come into contact with it, there's no way for you to really short it out to ground to where it would trip a regular breaker. Because like if you hit it with your shovel, a regular wire, there's both a neutral and a hot in that cable assembly, and you'll short those out to each other and it'll disconnect the circuit. But with this, with a single wire, you might cut through it with your shovel and nothing will happen because there's not a good enough connection back to the source to actually trip that 15 or 20 amp breaker. So this is not something that we want to leave it permanently installed for sure, but definitely is worth understanding what it can do and how we can actually route electricity through things other than just wires and make it work. Now, I think the next video I want to do on this sort of topic is to illustrate that electricity does not go to ground. It does not go to the dirt. And we're going to do that by using a generator, and we're going to use this exact same setup with the earth return, but when we turn it on, it's not going to work because, well, you'll have to just wait and see. If you guys have any other ideas of experiments that we should do with the single wire earth return setup, definitely let me know in the comment section below. I'll put a couple more videos here on the screen for you guys to choose from. Thanks so much for watching. I'm gonna go put a coat on now because it's like 30 degrees outside here in Minnesota. All right, we'll see you later.